This is Crystal for Rubyists. My name's Kirk Haines. My day job is as a developer relations engineer for Parity Technologies, but I've been doing Ruby for a long time, more than 20 years. And today we're going to talk a little bit about Crystal, and specifically Crystal for Rubyists. And what that means is, what does Crystal look like? What is it? And how can you leverage your existing Ruby knowledge in order to make you productive more quickly with Crystal? And the first part of this will be kind of like a talk, because I kind of want to go over, like an overview of a bunch of things. But it isn't going to be like a talk in the sense that I'm going to hold your questions till the end. If you have anything to ask, you want to talk about anything that you see up on the screen or anything that I say, interrupt me and let's talk about it, and let's just sort of see where this goes. The whole slide deck, as well as some code that was used in some of the slides, some code examples, and a few little, I guess you'd call them exercises, are all on GitHub, and you can access it through that QR code. If that QR code is too little for your camera to read it, you can grab it from here, and that's the URL to go to. So if you want to grab it and pull it down to your laptop to follow along on your laptop directly, you're welcome to do so. I'll give you just a few seconds there to grab that, and then we'll move on. So while we're waiting, let me ask this. Who in here knows what Crystal is? Quite a few of you. Cool. Now, who in here has actually written a line of Crystal before? Okay, cool.
Well, wait, if it's Ruby, it's Crystal, right?
It's sometimes, yeah. It's actually kind of surprising to me how much Ruby code will simply compile with the Crystal compiler, because the syntax is so similar, and there are a lot of things that are quite similar. All right. So if you need me to go back to that QR code, let me know, but otherwise I'm going to roll forwards, and let's just talk about a little bit about why Crystal. We're all here because we like Ruby. And I know some of us, like Keith here, we've been around a long time. We've been using Ruby a long time. And there are a lot of benefits to Ruby. And you can go and you can make a pretty exhaustive list of them. This is just a few quick little ones that I think a lot of people agree on. The blocks, the user-friendly syntax, the fact that Ruby is a very versatile language. You can use it for a lot of different things. And it's got some interesting sprinkles of functional programming in it that make it just enable that usability and that versatility. The dynamic typing is one of the things that honestly really drew me to it initially, and I think is one of the things that a lot of people look at as a benefit, the fact that most of the time you don't really have to worry about what the type of your thing is. You let Ruby figure it out, and you let Ruby tell you if you made a mistake. And Ruby has a really strong set of tools built around it and a really strong testing ecosystem. There's a lot of stuff to help you as a developer structure your projects and make your projects easier to work with. So there are some drawbacks to Ruby, and I know we can argue about some of these drawbacks, but generally, if you're trying to distribute a Ruby program, a Ruby binary, it's really difficult to do. There are some projects that have existed actually for a very long time to try to tackle this problem, and there isn't any one of them that has ever really taken off and dominated this space, because it's really a pretty difficult problem to solve, because there's so many dependencies wrapped up in a piece of Ruby code of any significance. Now you can write something and say mRuby. mRuby is a Ruby-like language itself. It's not really Ruby, because there are some significant differences, but it's Ruby-like, and it will compile to be an executable, but you can't go take your Rails app and turn it into an mRuby executable. Now, Ruby's performance has always been a topic of discussion, and with Ruby 3, that has been a significant focus, and it has gotten a lot faster. But nobody writes Ruby because Ruby is going to be a lightning fast 3D rendering engine. That's not why we use it. Its performance is fairly mediocre. Concurrency with Ruby is also kind of interesting because there's a lot of different ways to do concurrency with Ruby, and that's part of the tricks with it. You know, you've got fibers, you've got threads, you've got raptors, you've got evented systems, and that makes concurrency handling kind of an adventure sometimes. And then the static type checking in Ruby, it was added in Ruby 3. Actually, arguably a little bit before that because of the sorbet project, but Ruby 3 also has something called RBS. So if you want to have static type checking on your software so that you can really be more certain that you aren't making type-related errors, you can use it, but it is a bolt-on, and it has some limitations. It's not really... When you're writing code, it's not fluid to use RBS. Now, these are some of the drawbacks. And Crystal has some answers to some of these things. It is syntactically extremely similar to Ruby. You know, if you look at this code, that first little snippet, it's the same, Crystal or Ruby. And the next two snippets are almost the same. The one on top is Ruby and the one on the bottom is Crystal. The only difference between the two is that in Crystal, if you're declaring an array, you have to tell it what it's going to store. So you have a little bit of typing information in there. Yeah, it's kind of little on this screen. I had thought maybe the screen was going to be bigger, but you can see that bottom line there where it says array, there's an int 32 in there to tell it what the type of the array is, but that's the only difference. Go. Yeah, so actually I just minimized it completely out of view. Where'd it go? All right. Yeah, I minimized my view of it. There we go. I don't think...
Is that three-dot menu on the right maybe? Is there a maximize?
Did you do like a full, like going in full screen or like F11 or?
Yeah, I'm not sure why it's not showing me the normal full screen controls right now when I'm plugged in, but I guess we'll just roll with it here. So Crystal is a compiled language. It compiles your code down to an executable, and it's built on top of LLVM. Anybody here use Rust? Okay, so you know how that works. Rust also compiles down to LLVM. So it and Crystal share that common layer underneath. And this is just a little snippet just showing you that if you build something with Crystal, it is in fact a ELF executable on my system. Yeah?
Saying F11 will give you full screen.
Well, let's try it. No.
Oh, Command Shift F.
Nope. Anyway, the binaries tend to also be very fast to execute. In the repo that you can get from that QR code, there's a fib bench directory that has 4 implementations of a simple Fibonacci calculator that just recursively calculates Fibonacci numbers. And on my laptop, these are the timings for those. So you can see that Rust is a little bit faster, but Crystal outruns everything else by a substantial margin. And this was simply calculating the 40-second Fibonacci number, because if I go bigger than that on my laptop, Ruby's really, really slow. And if I go smaller, everything happens too fast. So that's the reason for that number. So Crystal has some answers to some of these these things while still remaining a versatile, productive language with a lot of the same syntax as Ruby. So if you don't have Crystal installed on your system and you want to install it, it's really easy to do that. And for once we're done with kind of the me talking part of this and we're to the you guys playing part of this, you might want to install it if you want to play with it and ask me questions. But if you go to crystallang.org/install, it's got guided installation steps for any operating system you might be using out there. And if you need a second to grab that URL, I can wait here a second. But it's just crystallang.org/install. And if you want to just play on your browser without installing anything, you can go to play.crystallang.org and you'll have a in-browser console where you can type code and you can run it and see what happens. It's a full uncrippled Crystal running there and letting you see what happens. So it's really nice to play with little code snippets and things like that. So I'm going to go through really quickly what the differences are between Ruby and Crystal at a very high level. And again, if you have questions about anything that I say, interrupt me. This is a conversation if you want it to be a conversation. And the first thing I want to say is that while Crystal looks a lot like Ruby, and in fact there is a lot of Ruby code that you can just throw the Crystal compiler at and it'll build it and it'll run it, Crystal isn't Ruby. There's some significant differences. It's a statically type-checked compiled language that doesn't have a lot of the dynamic qualities that Ruby has. So there is no eval, there is no send. It's possible to get a lot of the same capabilities using a different mechanism, but those things don't exist in Crystal. And so you got to keep that in mind, that it's not just a funny Ruby. It is actually a different language. It's just one that leverages your Ruby quite extensively. And I also want to mention here, just because it's a historically interesting thing, the reason why Crystal looks so much like Ruby is that the people that originally built it, they built it using Ruby. The first Crystal compilers were built with Ruby. And the original goal was basically to take Ruby and see if they could make a compiled language that looked like Ruby and felt like Ruby, but was compiled and was fast. So that is the first difference. Ruby's interpreted, Crystal is compiled. However, there is an interpreter for Crystal. Right now it's considered experimental. There's some things that don't work on it, but you can actually run a large subset of your Crystal code as interpreted code, just like you would Ruby. Crystal is dynamically typed, or Ruby is dynamically type checked. What that means is that the Ruby interpreter is checking the types of your data objects at runtime, and if you get something wrong, you're not going to know it until you run your code and Ruby figures out, oh, there's a mismatch here, and throws an error. Crystal is statically type checked, which means that when the compiler builds the software, it goes and it checks before it ever builds the executable to make sure that all of the types make sense and match the way they're supposed to. And like I mentioned before, Ruby does have static type checking with RBS or sorbet, but it is not directly integrated into the language. It's kind of a bolt-on, so it's a little bit different. So here's a quick example. What happens if you do this in Ruby? Yeah, so Keith said it's an error. If you run it in Ruby, and again, unfortunately, this might be a little hard to read, but Ruby gives you a type error because Ruby doesn't know how to add a string to a number. If you do the same thing in Crystal, it's also going to throw an error, but it will throw it at compile time instead of at runtime. And it's going to give you an explanation of what's wrong. And what's wrong is that it has an unexpected argument to the number. It expected it to be one of those types, and it wasn't that type. It was a string. And then it goes and it tells you what all of the things are that it could be. Now, Crystal does have type inference, which means that in a lot of cases it can figure out the types of things, so you don't have to specify those types. Back in that early example where you had the array with the type specified in the array, if in Crystal code you went and you just used the syntax to specify a static array with strings in it or whatever, Crystal's going to see that and it's going to know, okay, you mean an array of strings, and you won't have to specifically tell it that you have an array of strings that you're storing strings into. It's only when it's ambiguous and you can't figure it out that you have to tell it what your types are. And so in this example, there's nothing in there anywhere that's telling Crystal what A is or what B is, whether they're numbers or whether they're strings. And this will work exactly the same in Crystal as it does in Ruby. Just like that. No difference. Same code, both languages. Now, in Crystal, because it was inspired by Ruby, and Ruby informed a lot of the design choices, a lot of the method names are identical, so a lot of your code will work identically. All of this code here will work exactly the same in either language. You run this and you'll get the same almost the same output. There is a difference in how scan in what is returned by scan as far as how regular expression matching is. There's a slightly different data type that's returned, but all this code will execute exactly the same. But this will not. In Ruby, you do time.now. Crystal doesn't have a time.now. It has a time.local or a time.utc. Depending upon whether you want the time now in local time or the time now in UTC time, but it doesn't have a time.now. And that one, when I was first working with Crystal and I was porting some of my code, I could not figure out why it didn't work because time.now. Why isn't time.now not working? And it took me longer than I will admit before I realized that it didn't work because it wasn't implemented and I didn't have the right method. And so you will run into some places where those things are just different. Inject is another one. Inject on an array in order to loop over an array and execute a block on it and gather up a result. It's called reduce in Crystal. A lot of these name changes, by the way, are inspired by Go. Where there are name changes, in a lot of cases, it was because the authors thought that another language, typically Golang, had named it in a way that made more sense. And so rather than carrying on with the Ruby influence, they chose something that was clearer or made more sense to them. And then sticking with our Fibonacci theme, that piece of code down below, there is two really, really, really terse ways of very efficiently calculating Fibonacci numbers. And the one in comments is Ruby, and you can calculate more or less any Fibonacci number that you want with that, and it will be very fast. You want the 1,000th Fibonacci number, that little bit of Ruby will give it to you, and it'll be very, very fast. It's slightly different in Crystal, because in Ruby will cast between your regular integer types and a big int if you overflow that integer. So when your number gets too big, Ruby will say, oh, it's too big, time to use big int, and it will transparently cast that for you. Crystal doesn't do any of that automatic casting. And so in order to implement this in a nice, tight, terse way in Crystal, we just use big int right from the beginning and avoid that issue of casting. So you can see the code's almost the same, but just that little bit of typing difference in there. Yeah?
Don't you think you could maybe start with the big int type? You could use the same way that you wrote in Ruby, or like reduce method in Crystal? I'm not sure.
Oh, so yeah, so
if you started with the big int.
Yeah, so that's basically what I'm doing. So if you look, so in Crystal we have, in Crystal you have to tell it for a hash or an array where, I'm on the wrong window again. Having two windows, all right, so this part here, we're saying we've got a hash and the key is 32-bit integers and the values are big ints. And then what we're doing is we're just casting just the very first value that's going to go into there as a big int, because when the math happens then in the next part, because one value is a big int, just like in Ruby, if you're doing integer math, you know, you don't have to specify your types all the way through. You know, it will, you know, if you have an integer and a float, it will say, okay, I guess the whole thing needs to be a float. Well, because we have a big int and regular ints, it's going to say, okay, the whole thing needs to be a big int, and so it converts it all to big int. So it can stay nice and terse and concise, but you do need that little bit of extra typing information in there in Crystal that you don't need in Ruby. Yeah?
What does happen on arithmetic overflow in Crystal?
It depends upon the math operators that you use. For all of the math operators, there's two variations. One of them will throw an error, and the other one will wrap. So, you know, if you're doing multiplication or addition or something, and maybe have a use case for just wrapping it back around, there's an operator that will do that. Now, concurrency, I mentioned it earlier, and concurrency is one of those things that's quite a bit different. Ruby has fibers, threads, ractors, and via gem libraries, you have event-based concurrency. And so when you're trying to do something that is concurrent in Ruby, it can be quite a bit of work. So this is a fiber-based Fibonacci calculator. It sets up a fiber, and then every time you resume that fiber, it calculates the next value of the Fibonacci sequence. And you can see that, yeah, go ahead.
Given that there's no I/O going on, what is the benefit of using concurrency at all?
There isn't any. It's just an example. Okay. Yeah, there is absolutely no benefit to this. Yeah, it is simply an example of a fiber that's out there separate from your main program. And so what we're doing here is that every time we allow that fiber to execute, it'll calculate the next number and then return it. But what we have to do that is we have to do a lot of manual herding of that fiber. We have to declare it, we have to yield to it, we have to resume it. And if you're doing anything that's really complicated, all of that fiber herding can get really involved. You know, there's a lot of little details you have to keep track of if you're trying to write fiber code and do it all yourself.
I guess with Raptors you're using multiple CPUs.
Yeah. And I didn't do a Raptor example, mostly because I ran out of time to pull one together. But nobody's really using Raptors yet anyway, because there's still some growing pains there. And this is the same thing in Ruby, written with threads. And so you can see that it's similar. There's some things that are a little bit different, but written with threads, what we're doing is we're feeding that value into a queue, and then we're popping the values off of that queue. Yeah?
And the same comment about this, unless you're using JRuby, in which case you are using multiple CPUs.
Yeah, if you're using JRuby, it'd be multiple CPUs. In regular MRI Ruby, it's still going to be one CPU, typically because of the global lock that is on those in order to prevent conflicts between shared data. Now, when we do it in Crystal, it's a little bit different. Crystal looks, if any of you have ever used Go with Go's Go routines and channels, Crystal basically has that model of concurrency. And so what happens here with Crystal is we're spawning a separate execution unit. And you don't really have to worry about whether that's a fiber or that's a thread. That's kind of a background implementation detail. We're spawning an external unit that is responsible for calculating the Fibonacci numbers, and then we're communicating to it through a channel. And you can think of a channel as a one-directional pipe. So you can feed data in one end and you can pull it out the other end. And this is how all concurrency works in Crystal. So you have coordinated sequential processes that are talking to each other through these channels. It doesn't have a lot of the same, with Ruby you have to make these choices. Am I going to use threads? Am I going to use reactors? Am I going to use fibers? Am I going to use some combination? Am I going to use fibers with threads? And you have to do a lot of things very manually to handle all of that. With Crystal, it hides a lot of those details. If you turn on multi-threading, because right now multi-threading is an option with Crystal that you can turn on or not when you compile your program. If you turn on multi-threading, it will have one or more threads with fibers running distributed through those threads, but you don't have to worry about herding any of that. You don't have to worry about managing any of that. It manages it all for you. So all you have to do is send your communication to your processes, get your communication back from your processes, and let it worry about handling all of that. Now, some other just little differences. This is, yeah, Ruby libraries are gems, Crystal libraries are shards. And just like with Ruby you have a gem command, in Crystal you have a shard command. The actual low-level management of those is a little bit different because shards uses a YAML file to describe everything in it, since because Crystal is not a dynamic interpreted language, you can't describe your library in code within that. So it's described in YAML, and it parses the YAML to get the information out. And just like Ruby has bundler, Crystal has tooling that is inherent in the language to allow you to do a lot of the same things that you do with bundler and with shards. And somehow I got that slide in there twice. So this is a quick example when it comes up. There we go. This is a quick example of something you're probably familiar with. This is how it would look if you wanted to create a new project with bundler. You do bundle gem, and then you can give it some command line options to tell it what kind of test suite you want to use and how you want to do your CI and whatever, and it'll go create your stubs for you. And Crystal provides the same basic tooling in a slightly different shape. The Crystal command itself has this functionality, so it's not in a separate tool. So you can just do Crystal init, and you get much the same thing, just in a different tool. Now, testing is one of the things that I think in Ruby is a real strength. There's a strong testing culture in Ruby. Yeah, go for it.
Is Crystal init only for shards, or is it for programs as well?
Both. Yeah. So there's two where it says app there. If you change that to lib, it will change very slightly what it generates to be a library versus something that's meant to be executed separately. Yeah, so Ruby has strong testing history, and the two main testing libraries are RSpec and Minitest. And Crystal essentially has the same thing. Its testing library is simply called Spec, and it's built in to Crystal, and it is extremely similar to RSpec. Slight differences, but extremely similar. When you look at a Crystal spec, if you're familiar with our spec, you can read it. And likewise, there is a mini test that actually was implemented more or less as a direct port of Ruby's mini test. And so if you like test unit style tests, that's available to you as well. And so this is just an example. Actually, it's an example pulled out of a real library of what the specs might look like in Crystal. You know, it's got the same describe, the whole it syntax, you know, event.name.should equal test event. So it's very, very similar to our spec. Slight differences, EQ versus EQL, some things like that, but more or less, if you can read our spec, you can read Crystal tests. And then, yeah, kind of wrap up back to the beginning. Crystal isn't Ruby, but its syntax is close enough that you can use your Ruby knowledge to bootstrap yourself into Crystal really effectively. So this is the part where I'm done just talking, and the part where maybe we work on something. You know, we pair program, or we talk through something, or whatever it is you guys might find valuable. One of the things that I found really valuable when I first started learning Crystal was just going and taking pieces of Ruby code where I knew the functionality, I knew how it worked, and rewriting it in Crystal. Because sometimes it's extremely trivial, but you can see the little differences, and then every once in a while you run into something that is significantly different, and so then it sort of breaks your brain. And so I had, I guess, two concepts in mind here, and one was we can just go to exorcism and take some of the Ruby tasks that are in exorcism. How many of you are familiar with exorcism? Maybe I should explain exorcism first. I made an assumption that seems to be an erroneous assumption. Exorcism is a website that is intended to teach programming and intended to teach programming languages. And it does it by providing, for any given language, and they have dozens and dozens and dozens of them, they have programming tasks, little tiny challenges that each teach individual concepts. And you can go right in your web browser and you can code and you can work on those challenges and you can run your tests, and when they pass, then you get to move on to the next exercise. And so it's a really cool way to learn a language. And they have both a Ruby track and a Crystal track, and honestly tracks for just about any language you can think of, and a lot that you've never ever heard of. So if you've never looked at exorcism before, it's a really cool thing to take a look at. And even without, I was just looking at why the URL is blocked by something down there, but even without doing anything with Crystal, I would say exorcism is worth your time to go take a look at if you're interested in working on your Ruby skills or your Rust skills or any other language. And then the other thing that I have is it's actually in the repo. There is a Ruby program that was implemented as a dice roller for like a role-playing game. And I implemented it in Ruby, and there's a stub in the repo of a Crystal implementation, but it's not completed. And so the challenge would be to take the Ruby version and make it work in Crystal. And there is, if you want to cheat, a finished version also in the repo. But if you don't want to cheat, it's an interesting exercise in taking a working piece of Ruby that isn't just 2 or 3 lines and converting it into a piece of working Crystal. And I'm completely open to what people might be interested in. If you just want to ask me questions or you want to work on something, this is your turn to shine. Yeah.
What's something that you found that Crystal isn't great at? Like, when do you still yourself go to Ruby?
What's something? Okay, so I'm going to repeat your question because the microphone, yeah. So he asked, what is something that I found that Crystal isn't great at where I would go to Ruby first? And that's an interesting question. I think that for most significant projects, most projects that are intended to have some longevity, Crystal is comparable to Ruby. I mean, there's reasons for one or the other. If you really like the Rails ecosystem and you're building a website, it's hard to go wrong with Rails. But there are also very productive options in Crystal. I think that probably the place where there might be a difference is if I have something where I really, really, really need that dynamic code evaluation. Like I said, there are ways around it that I haven't gone into in this because, there be dragons there. If you're familiar with Rust has macros. Crystal has macros too. So you can write, Crystal has a macro language, which is a Crystal-like language that exists only to write code. So it's code that writes code. And so, doing that, you can do all sorts of dynamic looking things. But without going there, anything where you really need that dynamic code execution, or anything that maybe is just a quick, you don't care if it's might have typing errors that you're not going to run into anyway, because it's not going to be in production forever. It's some quick little thing you're going to bang out, you're going to get a task done, and you're done. All that kind of stuff, I think Ruby is definitely better for. For the other stuff, I think it's a much harder thing to decide that one is better than the other, because they're pretty comparable. Yeah.
So, what are things that in the real world that are powered by Crystal?
So that's a good question. That it's something that is growing. There's
every language has characteristics.
Yeah.
What's something that what's an application area that suits Crystal well?
So a lot of it is fairly similar to Ruby in a lot of ways. I mean, there's a lot of web development that happens with Crystal. There's some very productive web development frameworks for Crystal. There's also, I think the biggest project that I'm personally aware of is something called PlaceOS. It's a infrastructure management system. So you have some giant building with a whole bunch of complex mechanical systems and rooms to reserve and all kinds of stuff like that. A hospital or an office building with offices and desks and that are being reserved and stuff like that. PlaceOS is a system that manages all of that. And some very, very big companies like Cisco use it, and large hospitals use it and things like that. And it's all written in Crystal. But it has a lot of overlap with Ruby in where it is currently being used. I know of a company in Las Vegas that is a small Twitch competitor that uses it for all of their infrastructure. And I know that there are people that are using it for gaming development, because this is another thing that I didn't go over because too much complexity and too much talk. But Crystal has a really, really, really nice facility for interfacing with C libraries. Ruby is pretty good at that, but Crystal is just stupidly easy. Basically you can just link to a C library and use it almost like Crystal code. So it's really nice for interfacing with graphics libraries and things like that. And I know some people are doing that. Yeah.
So does Crystal have plans to deviate from Ruby in terms of syntax? Like if Ruby comes up with new syntax stuff?
So it's not really that Crystal has plans to deviate from Ruby. It's just that As Crystal is innovating on their syntax for like things like pattern matching, there's ongoing discussions in the core development community on Crystal. And Crystal is actually a very, very open development environment. Anybody who wants to get involved in actually working on the core of Crystal can. It's really open and accepting in that way. But there are ongoing discussions about language features, whether they're from Ruby or from other languages like Go, or Elixir or wherever, that might be good ones to implement in Crystal. And some of those things will be followed and some won't. Pattern matching is an example, because pattern matching is something that has been discussed recently. Yeah. Keith, yeah.
Back where you were talking about the absence of the time.now method.
Yeah.
In Crystal, can you reopen a class like you can in Ruby and add a method?
Yeah, so the question is whether in Crystal you can reopen a class like in Ruby and add a method, and you absolutely can. It's exactly like Ruby in that respect. So if you wanted to make a Ruby compatibility layer that implemented that stuff, you can do that. Yeah, and actually Crystal is implemented in Crystal entirely. So, basically down at the low level, it's reopening itself all over the place to add things.
If you didn't mention it, sorry.
Oh, yeah. Oh, I guess it's
If you didn't mention it before, is there like a central person behind Crystal?
So there was a central person, but it's more now of a community effort. And I can't pronounce his last name. His first name is Ari, but he's from Argentina. And he was a longtime Ruby guy. He's still in the Ruby community. But there's a consulting company in Argentina, Manus Tech, that provides a lot of the monetary support for Crystal. They have some developers who are on staff specifically to work on Crystal because they use Crystal with a lot of their clients, but it is very much a sort of a decentralized development environment. It's just shepherded by Manus Tech right now. Are we running out of questions? Okay, cool. I mean, if you want to hang out, we've got the room until 2. So, if you want to hang out and ask me more questions, or you want to work on some code or whatever, I'll be here. Otherwise, I'm not going to keep you all prisoner. You're welcome to go mingle and do your thing. Thank you all for coming.
So, how robustly has the Golang model of concurrency been worked on?
Pretty robustly. I mean, it's in pretty heavy use. And speaking from my own experience, it's really easy to use it. It is a little different. I mean, there's certain thought processes that take a little bit of getting used to when you're talking about passing messages around and receiving them like that. But it's pretty solid. The thing that isn't quite there yet is just in general with the language is the multi-threading support, because there's certain, you get into resource sharing issues, and there's a lot of the standard library that still shares data, and so isn't itself thread safe. And so when you turn on multi-threading, there's some risks, which is why it isn't enabled by default. But as long as you pay attention to those things, that also is working pretty flawlessly now.
Yeah, I mean, that's always been the nicest thing to me about Golang, and everything else about Golang feels wrong. I'm sorry, but...
Yeah. No, I mean, I'm with you there. Golang is one of those languages that I've used it before, and I understand, okay, the fact that you've got a standard library that's statically linked, so you can just share your binary anywhere. That's pretty useful, but it's just kind of a ugly, no fun language.
It always feels to me like, nanny programming. Like,
Yeah.
It's like you can't do what you want. You can only do it Rob types way.
Yeah, yeah.
I mean, I shouldn't complain about that because the source, but still.
Behind you, yeah.
One question, I was actually pondering writing something that was both Ruby and Crystal.
Uh-huh.
Supporting basically a standalone library apart, but it would both need to run in Ruby and in Crystal for a while. Was there some times where, like it literally sources the same source code?
Yep.
Both Ruby and Crystal, and is there a progression? Like, what's the strategy for? I've got a section of code that's production, and I need to move some of it to Crystal, but it also still needs to be used in Ruby in a different,
Yeah.
library that's used by both.
So I've got a couple thoughts there, and I'm not sure if this exactly applies to what you're talking about, but there is a library, and now that I'm up here on stage, I'm blanking on its exact name. It starts with an A. That lets you embed Ruby in Crystal, essentially, so that you can run both and pass data back and forth between them. But it sounds like you're saying you've got one body of code.
Yeah, it's actually the source code itself, because it's basically standalone some classes that wrap some JSON and do some very simple
Uh-huh.
things, but moving it to Crystal specifically for a concurrency perspective,
Uh-huh.
it's basically parsing a huge, massive JSON file in a parallel fashion and stuff like that. But a lot of the utility classes are used elsewhere in the Ruby code because it's the same single lines or same
Yeah.
subsections in JSON, and moving that into a Crystal, so that you're literally the exact same source code file that we sourced by Crystal and by Ruby.
Yeah. I mean, you can, Crystal will compile something even if it's called .rb. Yeah, yeah, yeah. That's actually in some of the examples that you didn't see. That's exactly what I did. Is I had one file called .rb and I just compile it. Yeah. So you can actually physically use the same file as long as it'll compile.
And even if the requires, it doesn't always have to put that CR will also get it.
Yep. Yeah. You can just require blah 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 .rb and it should work. Yeah.
And does Crystal generate a single binary?
Yeah, it generates a single binary. So like, here, let's just go, well, actually, let's do this. So if we do, if you want to see all of the steps, you can do it PST, and then -release builds a slightly optimized version. Now the compiling is a little bit slower than say Golang, because at the LLVM level it's applying quite a few optimizations, and so most of the time taken is waiting for that final step. But then if we do a, oh, I edited it and then messed that up, but that's okay. It's still built. Oh, it didn't build. Okay, but I've got the Rust version there. So you can see that the Rust version is about 3 megabytes. The Crystal version is 987 kilobytes. It's just a single executable. So basically the same thing, just, yeah,
Nice.
yeah. And that is actually strippable. So if you really wanted a very small file size, you can knock it down quite a bit.
How much of the rest gets stripped?
Let's find out.
Okay.
So it actually strips down slightly smaller. Yeah. 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 And that is, I guess, one of the negatives to Crystal is that if you have a very, very large piece of software, when you compile it, especially if you're running on a laptop that's not plugged in, it can take a little bit of time, but most of the time you aren't going to be compiling it in release mode. And if you compile it not in release mode, it's a lot faster. The thing that it doesn't do is it doesn't do partial compilation, so it isn't very good at reusing things that it already compiled, because you can reopen classes and you can change them and stuff like that. And so it's a really hard problem for it to know what it can actually reuse. So it ends up just rebuilding everything most of the time.
Oh, so even dependent files that will recompile them?
Yeah. If it doesn't, if it does cache them. So like, I just built that, and if I built it again, it was always small enough that there wasn't a lot of difference, but it was faster because it does cache them. But if I go change anything, it's going to rebuild everything. Yeah.
You mentioned there was an interpreter.
Yeah. So
Primary use case is just to have
so so the primary use case is debugging, because if you're writing Ruby code and you're hacking on something, sometimes the easiest way to debug it is just to drop into a pry session or use IRB. And so with the interpreted mode, you have it's essentially pry. Basically, they duplicated pry here. And so you have a pry session, and you can use it exactly the same way pretty much. But you can also use it just to directly run your stuff. So you can do, and actually the Fibonacci calculator is a terrible one because it'll be really slow on my unplugged in computer. But you can go ahead and run it. Oh, that was the binary. Yeah. So this is a terrible example right now because the interpreter is not as fast as Ruby. It's brand new. It's completely unoptimized, so it is not as fast as Ruby. And so on something like this, it's pretty slow. But it's really useful for debugging and things like that. Yeah.
You said it had some limitations.
It has some limitations because it is so new. If you go to the Crystal Lang install thing and you just install from an APT, or something like that, it's not going to be enabled by default because it's still considered experimental. So you've got to go to the sources and build it. But building it is incredibly easy. Basically, it's just you run make and it builds. And so you can go, if you want the interpreter, you go to the sources and it's make interpreter equals 1, and that'll build it with the interpreter enabled. However, there's some bugs basically. I mean, that's what the limitations are. There's just some bugs, and so there's some things where you start doing, especially when you start doing more esoteric stuff, there's some places, some edge cases where it just breaks. But because Crystal is implemented in Crystal, essentially what the interpreter is doing is it's reusing all of those implementations that already exist, that were already written in Crystal and are just compiled. It's just reusing them in an interpreted fashion. So. Yeah. If you guys have any other questions, anybody has any other questions at any point, I'm here and I'm happy to talk about it. I love Ruby, but I also really love Crystal. Thank you.